Okay, we're back. I I keep thinking about how they record game shows back in the day when we used to be able to get out. Alex Trebek for Jeopardy would bring. He lives in Templeton area, by the way, and drive down to L.A. And in one day, he would film one, two, three, four, five episodes of Jeopardy. And between every episode, he would just go and change his clothes. So that way, on the television, it looked as though it was a new day, even though it was literally the same day. And they had all the contestants bring five outfits as well in case they would win each given day. So I thought maybe I should change clothes between um, videos. Okay, well, that didn't happen. So the odds. The odds is simply a different way of expressing chance. So I want to remind you of that ruler that you have, or a yardstick, better yet, a yardstick. And why we call it a yardstick, I don't know, because it's 39 inches. You know why it's 39 inches? Because it's actually a meter long stick. If you try to buy a yardstick these days, you'll find it's, unless it's in a sewing shop, it's a meter long. And on the one side, it's got the numbers 1 through 100. On the other side, it's got the numbers 1 through 39, and they're equally spaced on each side. But if you take a measurement in inches, you could convert into centimeters. Or if you take a measurement in centimeters, you could convert into inches. The easiest thing is to flip your yardstick over and measure in the right unit. But I like that as an analogy, at least, for odds relative to chance. Okay. If I were to talk about the odds of an event occurring, I'm telling you something about the chance of that event. Okay. So first off, some odds. Odds. If I say the odds are 50 to 50 or 1 to 1, if you will, I'm telling you the chance is even, 1 in 2. If I tell you the odds are 60-40, I'm telling you the chance is 60% or 3 over 5. Literally, if I tell you the chances are 40 to 60, okay, that corresponds to a probability of 2 over 5. You might already speak odds, but if you don't, we'll give you an equation on the next slide to allow you to convert chances to odds. For now, I'm just saying odds and chances, they make sense to me both. Most people who don't gamble or aren't regular doctors who work in medicine, where they often report things in terms of odds and odds ratios, they're not familiar with odds. I'm just saying, for now, think in terms of odds and chance. They measure the same thing, but in different units. Okay, so here's how to get after odds, the chance from odds. Okay, if I say 50 to 50, you'd say there's a 1 to 1, and that gives you a ratio of 1 over 1, which is 1. 60 to 40, that's 60 to 40, expressed a different way, or 3 to 2. Or 3 over 2, which is a odds of 1.5. If I say the odds are 40 to 60, or 40 colon 60, or 2 to 3, that would be 2 over 3, okay, 0.67. 0.67 odds corresponds to a chance of 2/5. Okay. So let's get after the way to get the odds. The odds of an event, E, occurring is the chance that E occurs over the chance that E does not occur. So if the chance of something happening is 75%, then the odds would be 3 to 1. Because if something is a 75% chance, we'd say 0.75 over 1 minus 0.75. And that is indeed, 0.75 over 0.25, that is the 3. So there you go. An odds of 0.75 goes with a chance of, I'm sorry, a chance of 0.75 goes with an odds of 3 to 1. If I have a chance of 0.2, 0.2 over 1 minus 0.2, sometimes called 0.18, 0.8, I apologize, that's 1 in 4. The odds would be 1 in 4 if the chance is 0.2. I can also do, working backwards from the odds, algebra says if the odds is the chance of something happening over the chance that it doesn't happen, I'm going to do the algebra now. The odds is the chance of event E over the chance that E doesn't happen. I'm going to multiply both sides by the denominator on the right, okay, which moves effectively the denominator on the right to the left-hand side. The odds times 1 minus the probability of E is the chance of E on the right-hand side. So I've got, by collecting like terms, the odds times 1. I'm going to leave it on the left, but the odds times the chance of E, which is in a negative form, I'm going to subtract it and move it to the, subtract out the negative, essentially adding that. I get the chance of E times 1 plus the odds. And so now if I were to try to solve for the chance of E by itself, it's going to be the odds over 1 plus the odds. If I have the odds, I can find the chance of the event E. So if my odds are 5 to 4, as an example, 5 to 4, okay, the odds 5 to 4 over 1 plus 5 to 4 gives me 5/4 over 9/4. That's a chance of 5 in 9. So that's a lot of content. Not really too hard, but a lot of content. Let me just say, again, the key emphasis here is the odds relates to a chance. Rarely do I have students work from chances to odds or back. Okay, so this is a very old example, okay? But odds and chances are done via algebra. If you go to Las Vegas and want to place a bet, okay, you can place a bet on pretty much anything in Las Vegas, but if you can't find a place to place a bet on an event in Las Vegas because they say, well, we won't bet on that, you could always go to Great Britain or Ireland, or even online, and you could find the odds of anything. You could literally bet on whether Donald Trump will die of coronavirus. Okay, you could go to England and bet on that. Okay, so if you are told the odds by the folks in Las Vegas, like a 3-to-1 Clinton favorite, okay, that corresponds to a probability of 0.75 via our equation. If you're back in the day thinking Bernie Sanders was your presidential candidate and had an odds of winning the overall presidential race again in 2016, in summer of 2016, you'd say 0.0455 was the odds. You could create a probability from that. And the only thing that's awkward here is the odds are set up such that they are going to give Vegas or your bookie in England an advantage. The sum of the probabilities won't be 1. It will always be greater than 1 if you're using odds from bookies. So that's why you know you should never bet with people in Las Vegas, is the odds that they give you across all the events correspond to probability sum greater than 1, meaning they're taking money from you in the long run if you bet on enough things. Okay, so what about odds ratio? Well, the odds of something is the chance it happens over the chance that it does not happen. Well, in the top row, the placebo taking individuals or the aspirin taking individuals, okay, we could find the odds in each of those rows. If I tell you the chance P1 or the chance P2, you could solve for the odds ratio, which I will call theta. Now, unfortunately, we don't know P1 and P2, but we have a theta hat, an estimated odds ratio. And there's 2 versions of that equation. The first version is if I were to tell you P1 hat and P2 hat, you're done, because P1 hat over 1 minus P1 hat over then P2 hat over 1 minus P2 hat. And remember the parentheses in the denominator and the parentheses in the numerator. Figure out the parentheses in the numerator first, then go with a denominator, which itself is its own ratio. Some of you are saying, but I know how to do algebra. Well, fine, do algebra and do it your own way. As long as you get the right answer, we're fine. I will tell you, though, a second approach is if I were to have a contingency table where I've got 4 separate counts. And 1, 1, the count in the upper row, left cell, upper row, right cell, bottom row, left cell, bottom row, right cell. So N11 corresponds to first row, first column. N12 is first row, second column. N21 is the first, I guess the second column, first row. And then we have second column, second row. And if I multiply those numbers in the diagonal, divide through by the numbers in the other diagonal, you have indeed your odds ratio. Let's look at our example and do it both ways. Okay, so if I were to show you for aspirin and heart attacks, P1 hat and P2 hat, you could say the odds ratio is easy because P1 hat over P2 hat is P1 over 1 minus P1, and then P2 over 1 minus P2, that's 1.83. So please now check with your calculator, pause as necessary to check with your calculator that that ratio there is 1.83. So pause now. Okay, now that you've checked with your calculator that that's 1.83, you should verify you got it. If you didn't get 1.83, common mistakes are, again, forgetting the parentheses in each of the numerator and the denominator. I calculate them separately. And if you just string them all out, 0.0171 divided by 1 minus 0.0171, well, you know, if you don't have the parenthesis around the 1 minus 0.0171, there's going to be an issue. And then again, the second division, then the third division, if you just punch a bunch of numbers in without parentheses on your calculator, you might very well end up with that 1 minus 0.0094 ending up in the denominator rather than the numerator, which will cause your odds ratio to be off. Okay, so go back and double check if you got it wrong the first time through. Okay, now that you've verified you can get it, let's try the second approach that I claimed. N11 times N22 over N12, N21. We have that ratio being, my claim is again 1.83. Verify that you have that ratio as 1.83. Yay! Okay, so we are good to go. So I'm going to make the claim. The odds of heart attack are 83% higher in the placebo group. So you're saying, yay, they're 83% higher. Woo. I think, though, there's something really cool here. And that is the odds ratio looks sort of like a relative risk. Theta hat, which is P1 hat, over then 1 minus P1 hat, over then P2 hat, over 1 minus P2 hat. That looks a lot like the relative risk to me. In particular, my friend over here off to the left is the relative risk. So if we're talking a rare event, like a heart attack, something with a very low chance, something with a chance below about 5% or so, 1 minus about 0 is going to be about 1. That ends up being approximately 1. And similarly, 1 minus 0.0094, also that denominator of the denominator is about 1. So theta hat here is approximately equal to P1 hat over P2 hat, which is just the relative risk. So I'm happy with that. And the reason I'm happy with that is we can interpret a relative risk. If we can interpret a relative risk, we are good to go. Okay, so The idea here is you could always calculate an odds ratio, number one. Number two, you can calculate a confidence interval for the odds ratio. That's the next video. But then you could use the relative risk interpretation for the odds ratio, at least if the event is a rare event. Okay, so let's go after that. Okay, so here is a fun study. It's about owning a bird and developing lung cancer. You might think there's no relationship between the two. I've talked to some animal science students and some students who are like public health and biology, and they all say, well, maybe. And the reason is there's something in the bird feathers or the bird's skin, which is literally gonna just flake off, shed off over time. And if you have enough of that sort of dust in your house, if it may cause you, when inhaling it, to become more prone to lung cancer, well, no surprise. Okay. And the two possible ways we could study this, or actually three possible ways we could study this, I'll give you the stupidest first. We could take a sample of 100,000 people and say, do you own a bird, yes or no? Do you have lung cancer, yes or no? That's going to take a lot of time to sample 100,000 people. That's going to be very expensive. A second possible study is maybe take 1,000 people that own a bird and 1,000 people that don't own a bird and follow both groups over, say, the next 20 years and see if any of them develop lung cancer. That'll be expensive, but it'll also take a lot of time. The third approach is a paired case control study, like we're discussing here, where we literally went to a cancer hospital in Berlin, one that specializes in treating cancer patients, and we said, okay, we'll ask 239 people who have lung cancer, have you owned a bird as an adult, yes or no? And we're going to ask 429 people about two non-lung cancer, but a different form of cancer. So they're all in there for cancer. People of the same age, people of the same sex, people of the same racial group, and people of the same income category. So for each poor female Berliner who's African American, Berliner African American, a black Berlin resident, okay, who's female in the age 50 to 60, they're going to find someone who's fitting the same demographics, who has a different form of cancer, and yet another one. Okay, so you get two groups out there: the lung cancer group, and then the non-lung cancer group. And I would organize the data the following way. Response variable is corresponding to the columns, LC for lung cancer and no lung cancer. Okay. And I know of the lung cancer, there's 239 individuals and 429 without lung cancer. Again, it's a different form of lung cancer. And then bird, they have owned a bird as an adult, and of the 239, 98 said, yeah, I've owned a bird. And of the 429, 101 said, no, I have not owned a bird as an adult. So no bird as an adult. And I'm suspecting it'll be easy to get the other numbers because 328 of the no lung cancer patients didn't have a bird because 101 did of the 429. Similarly, 239 minus 98 is 141. So that is our contingency table. Now, the second question, calculate a risk of owning a bird for each cancer and non-cancer group. Okay, so for the cancer group, the risk of owning a bird is 98 of 239. That's just under half. For the the non-lung cancer group, 101 of the 429, that's under a fourth. So the risks of owning a bird appear differently, but if we were to try and calculate a different total, and I'm going to go with red here, of the 199 people who own a bird, half have lung cancer? That sounds wrong. And of the 469 individuals who don't own a bird, a third have lung cancer? That seems like a very high rate of lung cancer. Here's your hint. Yes, it is a very high rate of lung cancer. The way we gathered our data, we oversampled the lung cancer patients relative to the general population out there. You cannot conclude the risk of lung cancer in either the bird owning group or the no bird owning group in this retrospective case control study. So I'm going to go ahead and just undo all the red bits. And what we're left with is we can calculate a risk of owning a bird, but we cannot calculate the risk of having cancer in each the bird group and the non-bird group. So no, you cannot, because we oversampled among the lung cancer patients. But we still can get the odds ratio theta hat here is 98 upper left times 328 lower right over then upper right 101 times then lower right 141. And I think that after we calculate it, we have to give you an interpretation. The interpretation will be hard itself. So let's check the calculation. Nope, I don't have the calculation done. So I will have to do that by hand. So while I'm working this way on my calculator, you see if you can get the same number as I do. 98 times 328 divided by 101 divided by 141 equals 2.26. I got 2.26. 2.26. Did y'all get 2.26? I'm staring at the screen. I don't know why. Normally I'm used to seeing faces in the screen in Zoom, but I'm getting 2.26 here. I would say, interpreting this odds ratio, I'd say the odds of developing lung cancer in the bird owning group are 2.26 times the odds of developing lung cancer in the no bird group. That's sort of hard to grab onto. Yes, it is. But still, that's where we can stop for the moment, because the next chunk of information is developing a confidence interval for the odds ratio. My gosh. Oh, hold on. No. Let's give you one more bit of interpretation first. Yeah, bird ownership, lung cancer, good. We got the odds, good. That should be because lung cancer is a fairly rare thing. It's, less than 5% of people have it. That's about equal to the relative risk. So the relative risk is 2.26 or so. The increased risk is 126%. The risk of developing lung cancer if you own a bird is 126% higher if you own a bird than if you don't. So you more than double your chance of lung cancer if you have a bird as an adult. Okay, more than double your chance of lung cancer if you own a bird as an adult. That itself is goofy. And on that note, we're going to pause because that is so goofy, it's worth thinking about until next time. So we'll talk to you next time. Bye-bye.